Hi, in this video we are going to talk about residual networks, and basically this residual network is very important in the Ford-Fulkerson and the Edmonds-Karp algorithm. So let's get started. Basically we have the flow network, this G with the number of vertices and the given edges. This is the so-called flow network we have been discussing so far. And we are able to construct something called a residual network. It also contains vertices and edges, but maybe it contains more edges than the original one. The number of vertices is going to be the same. Okay, so I'm going to denote it with G prime. And basically we have the original capacity in the flow network, and we are able to calculate the residual capacity in the residual network. I denote it with C prime, which is equal to the C, so the original capacity, minus the flow in the original flow network. And it's always going to be greater than 0 because, as you may recall, this C is going to be greater or equal than the flow. So whenever the C is equal to the flow, it's going to be equal to 0. Okay, sorry for that, it is greater or equal than 0. But anyways, the C is going to be greater than F. So it's going to be greater than 0, this C prime residual capacity. Okay, so let's consider this graph. This is the original flow network with the capacities and the flow values. Okay, and we would like to construct the so-called residual network. So let's consider this edge, for example. We know for certain that the maximum flow can be 4 and we have flow 1. So basically we are able to flow 3 more units. So that's why we are going to have a forward edge basically pointing from the source to the vertex A, because we are able to flow 3 more units because the capacity is 4 and we have a single unit of flow basically so far. So as you can see, this is what we have been discussing here, that the residual capacity is the original capacity minus the flow. As you can see, if we make 4, so the original capacity, minus 1, which is the flow in the original network, it's going to yield 3. But what's very important, that because we have send 1 unit flow in this direction, we are able to send a single unit of flow in the opposite direction in the residual network. Basically, this flow value is going to be copied here. What about the next edge? We know for certain that we have an edge pointing from the source to the vertex B in the flow network, where the capacity is equal to 5 and basically the flow is equal to 3 units. So we are able to send 2 more units of flow. We just have to make this 5 minus 3 operation. But because we have sent 3 units of flow in that direction, we are able to send back 3 units of flow. Okay. As you can see, if we summarize, so if we sum up the values of the edges, 3 plus 1 is equal to the capacity of that given edge in the original flow network. 2 plus 3 is equal to 5, which is the capacity of the original edge in the original flow network. Okay. What about this one? We consider this edge. We know that the capacity is 4 and we flow 4 units. Okay, so basically the maximum amount of units in this direction. So we are not able to send any more flow unit in this direction. So that's why basically the arrow pointing in the direction of the A is missing here. But because we send 4 units in that direction, we are able to send in the residual network 4 units in the opposite direction. So that's why I said that in the residual network there may be more edges than in the original network. Okay, what about this edge? We can come to the conclusion that it has basically 1 flow out of 2 capacity, so we are able to flow 1 more unit in this direction, and we are able to flow 1 more unit in the opposite direction. As you can see, 1 plus 1 is equal to the capacity of the original edge in the flow network. Here it is true as well that we have 4, which is the capacity of the original edge in the original flow network. What about this edge? Basically, we see that we have 7 capacity and we have already flow 5 units. So we are able to flow 2 more units in this given edge. And we are able to send back, so basically flow in the opposite direction 5 units. Why? Because 5 plus 2 is equal to the original capacity of the original edge in the flow network. So basically this is how we construct the residual network. And why is it important? Because we are going to find the augmenting path in the residual network. And if we come to the conclusion that there is an augmenting path in the residual network, it means that we haven't found a maximum flow in the original network. And if we are not able to find any more residual path in this residual network, it means that it is the end of the algorithm and we have managed to find the maximum flow in the original flow network. So basically this is why it's crucial to construct the residual network, because we are going to look for the path in the residual network and not the flow network. But it's quite easy to construct it. We just have to consider the given edge capacity and the amount of flows that we have already flowing in that given direction. And basically we are able to calculate the edge weights in the residual network. Thanks for watching.